Welcome back. This is an Aleks training video on deciding the relative energy of electron subshells. An electron is not going to go into a subshell that takes a lot of energy to get there. If it has the choice of having something cheap or something expensive, it's going to have something cheap. If I were to give you the choice of having no homework or 10 pages of homework, you would pick no homework. It's exactly the same. Whatever's the cheapest energetically is what an electron's going to do. It's only going to go into a orbital that's high energy if there's no other choice. If every other orbital is full, that means that they're going to start entering these orbitals in the order of increasing energy. So you need to know which ones is higher energy than others. Now you'll see that the periodic table beautifully answers this. You can just glance at the periodic table and find out who has more energy, but I'll show you that in just a second. So if you can get a periodic table to look at, it would help you. You're asked to list these electron subshells in order of increasing energy. All right, so which one is going to have more energy? So first of all, let me give you a rule. This is called the N plus L rule. Okay, if you add the N plus the L together, okay, the subshell that has the highest N plus L is going to have the higher energy. Okay, let me write that down. The higher sum of N plus L will have the higher energy. Okay, so the N, remember, is your period, 3's here, 4's here. Your L, remember, is your subshell, so S is 0, P is 1, D is 2, F is 3. So if you're given, say, a 3D, what would be its its N plus L rule? Okay, 3D is going to be 3 plus, and now D is what? S is 0, P is 1, D is 2, so this is 2 plus 3, that's a 5. Okay. The next one is 3P. P is going to be, let's see, S is 0, P is 1, so this is 3 plus P, this is 1. 3 plus 1 is 4. 4S, S is 0, S is 0 and 4, so this is 4 also. And 3S, S is 0, so this is 3. Okay, well, I know that the lowest has to be 3S, the lowest energy. The highest has to be 3D, but I'm not sure about this 4S and 4P. The rule is if two electrons have the same N plus L, the highest N has the most energy. Okay, that means 3P has a 4 N plus L rule, 4S has a 4 N plus L rule, but the 4 has the highest N number. Okay. Okay, the highest N number would be 4S, so it's going to have the higher energy. So let's do, first of all, I'll answer the question, and then I'm going to give you something else. The question would be, I want 3S. That'll be my first one. What's my next energy? 3P. My next energy is 4S. And my next energy is 3D. Now that doesn't seem like I wouldn't have guessed this, because you wouldn't think that the 4S would fill before the 3D would fill. But it does happen to be that way. I'm going to show you quickly a picture of a periodic table. You should always have a periodic table with you. Okay? Now look here a second. You've got S's here, which are the hydrogen in the beryllium group. These are your S's. Here are your P's, boron through helium. All these are your P's. Here are your S's. Okay. Here are your D's. If you remember that the first period has one subshell, S. Okay, so helium, hydrogen, helium, that's S. The second one has two, S and P. Okay, that makes sense. There's nothing here in the valley. S and P. The third one has a D. Here's S, here's P. So where's the D? The D is one off. The scandium through zinc is in group row 4, but scandium through zinc is actually in the third shell. It's one displaced. So you're going to have 3S, 3P, and then 3D. Okay. Group 4 has 4S, 4P. Okay. Then, or this is group 5, 5S, 5P, and then 4D, so it's off by 1, and then 4F. Okay, so period 4 has 4 subshells, S, P, D, and F. Period 3 has 3 subshells, S, P, and D. Period 2 has 2, S and P. Period 1 has 1, S. That means that if you're increasing electrons, here's electrons going in here. That's 3S, then 3S2, then 3P1 through 3P6. If increasing energy is now going up here to 4S1, 4S2, and then back to 3D1. So 3D1 has more energy than 4S2. So your kind of picture that might be useful to make sense of this is if you were to simply draw 1S, 2S, 3S, 4S, we'll go to 5, 5S, and then 2P, 3P, 4P, 5P, then go up to D, 3D, 4D, 5D, then go up to S, or F, 4F, 5F, and then there would be a G here, except that we've run out of elements. We don't need it, but it's that same idea. If you are going to go into a shell, you're going to go into the 1S shell first, then you're going to go into the 2S shell next, then you're going to go into the 2P shell, and then you're going to go into the 3S shell. Okay. Then you're going to go into the 3D, then the 4P, and the 5S, 3D, 4P, 5F, then you're going to go into 4D, then to 5P, 4F, 5D. Now that doesn't make any sense if you're just writing arrows. If you can see that on the periodic table, the first energy level will be 1S, the next one 2S, the next one will be 2P, the next one will be 3S. Okay, so I'm going to do it one more time. The lowest energy level is 1S. Okay, the second energy level would be 2S. The next energy level would be 2P. The next would be 3S. The next would be 3P. The next would be 4S. The next would be 3D. And then 4P. Then 5S. Then 4D. Now 5P. And that essentially you're just following the periodic table, going from one to the next to the next. The very next one has more energy. So element 79 has more energy than element 78. And this is just an easy way to do it, kind of crib notes, so that you can know what's the next available energy level. Okay, thanks.